Hi, this is Alex Galt with Edina High School. I am looking today at connecting limits at infinity with what a vertical asymptote is. So you're going to be thinking about these limits that involve infinity and what that means for the function. So first we're going to define vertical asymptote, and we're going to be very thorough in this definition of vertical asymptote. So x equals a is a vertical asymptote if and only if one or more of the following is true. If the limit as x approaches a is plus or minus infinity, or if the limit as x approaches a just from one direction, either the positive or the negative direction, is plus or minus infinity, then you have a vertical asymptote. So some characteristics of vertical asymptotes. First of all, it's a vertical asymptote, so the equation would be a vertical line. It would be x equals some number. The y-coordinate is going to either increase or decrease without bound from at least one direction if it's a vertical asymptote. And it is possible to touch a vertical asymptote. Here's an example of a graph that touches its vertical asymptote. There's a vertical asymptote here because this part of the function, as x approaches 0 from the positive direction, so as x approaches 0 from the positive direction, our function is shooting down towards negative infinity. But as x approaches 0 from the negative direction, our function is approaching 0, and it actually has a value of 0. So it's touching its asymptote at that point. Another example is the tangent function. Anytime, if you think about tangent is sine over cosine, so anytime cosine is equal to 0, you have a vertical asymptote for the tangent function. With any rational function, you're going to find your vertical asymptotes when the denominator is equal to 0, as long as it's not a whole. A whole, like in this non-example, this is x squared minus 4 over x minus 2, but since x squared minus 4 factors to x plus 2 and x minus 2, x equals 2 is not really an asymptote, it's a whole in the function. So that's not an asymptote. Usually we look for zeros in the denominator, but you might have a whole, in which case you don't have an asymptote. All right, so we're going to look at this function. We're going to find the vertical asymptotes and the behavior near the asymptotes. So if I look at this function, I see that there's a 0 in the denominator in a couple of different places. So I'm going to go ahead and factor that denominator. I have 3 minus x in the numerator, and then I have x is a GCF, and then I have x squared minus 9. And then I have a difference of 2 squares, so I can write that as 3 minus x over x times x plus 3 and x minus 3. And x equals 3 gives you 0 over 0, so x equals 3 is a whole. It's not an asymptote. But x equals negative 3 gives you a number it gives you a number over 0, and x equals 0 gives you 3 over 0. So we have asymptotes at x equals negative 3 and x equals 0. We do not have an asymptote at x equals 3 because that's a whole. So now if I look at x equals negative 3, I want to look at the behavior near that asymptote. So I'm going to look at the limit. So the limit as x approaches negative 3 from the negative direction. So I'm a little bit smaller than negative 3. And when you think of a little bit smaller than negative 3, don't actually think of a number. Think of just something a little tiny bit smaller than negative 3. Well, if I take 3, so first of all, I know for sure that if I plug in negative 3, I have 6 over 0. So I know for sure that I have some kind of asymptote. Really, all I care about at this point is it positive or is it negative? I know that my answer is going to be some kind of infinity. I just need to decide if it's positive or negative infinity. So that's my only goal here. So now if I think of something just a little bit smaller than negative 3, I would have a positive on top, because 3 minus a negative would give you a positive value on top. I don't know exactly what it is, but I know it's positive. And then this part, this x, would be negative because it'd be a little bit smaller than negative 3. This part, if I do something a little bit smaller than negative 3, I'm going to still have a negative for that part. And then x minus 3 would be positive. Though it wouldn't, it would be negative. I lied. So I have a positive number divided by a negative number. So I know that this limit is going to be negative infinity because of signs. So that tells me, if I think about the graph of this function, as I approach negative 3, I don't know what's going on, but I do know that as I approach negative 3 from the negative direction, my function is shooting down to negative infinity. Now if I look at the limit as x approaches negative 3 from the positive direction, again, I would have positive Now I'm a little bit bigger than negative 3, so if I add 3 to that, I would get a positive. And then negative. So this would be positive divided by a positive, so this would be a positive infinity. So this function, as I approach negative 3, is going to, from the other direction, is going to shoot up. I don't know the exact shape, but I do know that the behavior near that asymptote is that they're pointing in opposite directions. To the right, it's pointing up, and to the left, it's pointing down. Okay, I can do the same thing for x equals 0. I can say, well, the limit as x approaches 0 from the negative direction. So I'm still looking at this factored version. 3 minus 0 would be a positive. A little bit smaller than 0, so x would be negative. X plus 3 would be positive. X minus 3 would be negative. So I have a positive divided by a positive, so this would be positive infinity. And that means that this function is then shooting up as we get close to 0 in that direction. And then the last thing I'm going to do is the limit as x approaches 0 from the positive direction. So there I have positive. This would be a positive, and then these would still be positive. So everything would be positive if I'm close to 0 in the positive direction. No. This would be negative because 0 minus 3 would be negative. So then I have a positive divided by a negative. So this limit would be negative infinity. So that means that if I think about this function as I approach 0 from the positive direction, it's shooting down. Okay. Again, I'm not sketching exactly what that function looks like, but I am giving you a rough idea of what the asymptotes are doing. All right. Last thing we could do is we could sketch a function with this behavior. So the first thing says, as x gets close to 1, the limit of my function is 2. Okay, but it also says that at 1, the value of my function is negative 3. So that means I've got a value here at 1 comma negative 3, and I have a hole here, and I don't know what's going on after that hole. And I don't really know what's going on before that hole, but I do know that as I approach negative 2 from the negative direction, my function is going down to negative infinity. And as I approach -2 in the positive direction, my function is going up to infinity. So maybe it looks something like this. There's more than one way to sketch this function, but the things that I would be looking for, I would make sure that all 4 of these facts are true. All right, so that's connecting those limits to asymptotes a little bit. That should help with the definition of what is an asymptote. And I could define my function with a value here, so it is okay to touch an asymptote. It's just unusual to do so. That's all I got. Good luck.